Hi, in this video, we're going to explain the fire alert system which we have developed for assignment 2 of distributed system module. Here is our team. I'm Dilanka, Taraka, Ratnayaka and Gunaratna. Let me give you an abstract idea of this system from the user perspective. Simply, fire alert is fire alarm monitoring system. These are the features the system provides to the user. It has a desktop client application which runs on a PC, a web dashboard which is accessible over the internet from any device, and also the fire sensor. It is the device that measures the smoke level and carbon dioxide level of the nearby environment. When the fire sensor fixes in a location, it should be registered to the system through the admin dashboard. Then, the sensor will send the readings to the system in every 10 seconds. Admin dashboard enables the user manage fire sensors and monitor current readings and status of them. And the web client shows the same details of the sensors. The main objective of the system is getting an immediate notification in an emergency. In case of fire, the administrator will be notified through the email and SMS alert immediately. That's all about the abstract view of the system. Let's see the implementation behind the system to achieve that abstraction. In this section, I'm about to explain the high-level architecture of the fire alert system. There's a REST API. It is the central service provider of the system, and there may have one, two, or many fire sensors in different locations. Once the sensors registered to the system, they connect to the API over the internet, and they start to send sensor readings to the API repeatedly. Then, API stores these readings in a remote database that connected over the internet. For this system, we used MongoDB Atlas service as the cloud database. Another main implementation of the system is RMI server. It provides the service to the desktop client application which I mentioned in the introduction. Here is another server. It is the server that hosted our web client application. There can be multiple devices connected to the web hosting server through the internet. Finally, we have third-party services that connected to the API to send emails and SMS notifications. MessageBird and SendGrid services are used as SMS and email services respectively. These services also connect to the API over the internet. Well, that's all about the system architecture. Let's see them in practice. Taraka will explain the functionality of the RMI server and client.
In this section of the video, I will show the functionalities of RMI server and the desktop client. Here I have opened some sensor applications in order to imitate the behavior of the actual real-world sensors. These first three sensors are already registered to the system, and the fourth one is prepared to be registered to the system. And you can see the desktop client here. Here the desktop client is opened using the guest login, and we have the admin login as well. And as well as the RMI server is up and running in the background. If I summarize the functionalities of the RMI server and the desktop client before showing the demonstration, the desktop client connects to the REST API through the RMI server by invoking remote methods that are exposed by the RMI server through a public interface. For every 15 seconds, RMI server checks CO2 and smoke level, and if one of those level has gone over level 5, it will call to the SMS and email services endpoint in order to send emails and SMSs to the admin. And the desktop client refreshes the details of the states of the sensors for every 30 seconds. But in order to make this video shorter, I changed that interval to 5 seconds. We can change that value by changing these points of the code. And if CO2 or smoke level has gone over level 5, desktop client will show those sensors in red color. And there are two types of login, as I mentioned before, admin login and the guest login. Using guest login, we can only see the sensor details and the states. Using the admin login, in addition to seeing the details, we can register a new sensor to the system. We can edit the details of existing sensors, and we can delete existing sensors. Now let me show how the RMI server and the desktop client works. As I mentioned before, this sensor dashboard is often using the guest login, so we can only see the details of sensors. We cannot do anything more. If I change the details of the sensors, you can see that changes in the dashboard as well. Let's try to deactivate one. It will take a moment. Yes, it changed. Now I have to log in using the admin logins to show other functionalities. It will show an error if I use invalid credential. Now I use the correct password. You can see now I logged as the admin. Therefore, the edit button and delete buttons are available now, and here is a new option to register a new sensor. By using that, let's try to add this fourth sensor to the system. In order to do that, we need to copy this serial number on the sensor as the sensor ID to the database. You can see it will update after 5 seconds. Yes, it updated. And let's try to edit existing details of sensor. We'll give it one. Yes, it updated. And if we try to change these details again as we did previously, you can see those changes are again displayed in the sensor dashboard. If I change level over 5, you can see that sensor will show in red color, and as well as the now RMI server will send SMSs and emails to the admin telling there is a smoke or CO2 level increase. And let's try to delete existing sensor by clicking this delete button. You can see it is deleted. We will see the sent SMS and emails and the web client in next section of the video.
Now I'm going to show you the web client application. Let's see how it works in action. As you can see, there are a couple of files and applications on the desktop. I've already run 2 of them for the demonstration. Actually, these are the portable versions of executable files that were packaged with different IDs. This is the GitHub repository of the web client application. It has deployed on GitHub pages. I'm opening it in new tab. Here you can see the web client application with 5 registered sensors with details. Let's activate the sensors. When I activate them, web client gets updated. As the requirement, it should be updated in every 40 seconds, but I reduce it into the 2 seconds for the demonstration. I'll show you it in the code. Let's open app.js file inside the source folder. In here, we can set the refresh rate of the application. Let's back to the demonstration. When the readings of smoke level and carbon dioxide level change, the changes are visualized in the dashboard. Let's see how it works. Yeah, you can see the web client application also gets updated. Now, time to see the system behavior in an emergency. For that, I'm reducing the window size of the web browser. Here is my email inbox that registered as the admin. And also I have opened the desktop version of my mobile messaging application right here. And also the RMI server is the responsible component to identify emergencies and send emails and SMS notifications. Actually, the RMI server is up and running right now in separate machine. You may be noticed I didn't change before any levels over 5 because the system identifies it as an emergency, and then RMI server will send alerts to the admin. Now time to see it and how it works. Let's change the smoke level and carbon dioxide level. I set the smoke level to the 8 and carbon dioxide level to 10. Yeah, the sensor location background changed to the red color, and email should be received now. Yeah, now you can see the email has been received, and also the SMS notification also received now. Let's open and see it. It says there is an fire emergency on the 5th floor, room 508. And let's open the email also. In here you can see the same details that received in the SMS alert. Apart from that, here is the smoke level, carbon dioxide level, and the time which emergency identified, with a link to the web client application to see the real-time situation. That's all about the system functionality. Thank you for watching.